Okay, so now we're in the next section, equality. So I'm going to bring more of the pieces of the puzzle together. Again, like I said, we got this big old puzzle with 1,000 pieces, a little bitty small pieces, and what we're doing is we're starting to build a pattern, right? So I'm going to explain a little bit more to you and add to the knowledge that you already have. Again, if you are here on this channel and you're just finding us and you would like to follow along with us in the curriculum, it is actually linked in the description and it is free. You don't have to pay for it. So have at it. Again, join us and follow along. Okay, so let's get into it, okay? So here we go. Equality. Loose equality with double equals. We're going to start here first with double equals, and then we'll explain triple equal. In the section Booleans, we learned about the comparison operator. Understand what a comparison operator is. Remember what that means. Double equals and not equal. That's what that exclamation point means, and we say not equal, which tests whether two values are equal or not. You may have the word test, you may have the word check. We use check more often than we use test. Equals or not equal, respectively. However, there are some quirks with using double equal operator, which occurs when we use double equal to compare different data types. We talked about the data types. What are the data types? In JavaScript, everything is an object. Everything on the right-hand side of an assignment operator is a value, which falls into the category of a data type, some type of data, right? And some type that we're using. And so here we have some examples here. You may be familiar with this. You may understand it off the top, or maybe you don't. So I'm going to explain. Here we have three console logs. One, we're comparing number 7 double equal with the string number 7. 0 equal to false, 0 equal to an empty string. And they're all true. Now, if you go back to MDN, Mozilla, which is MDN, and we explain truthy to you, we understand that 0 from the binary code, binary numbers, 0 is false. So we know that this 0, which is a number now, which is a data type, versus this Boolean with this soft equals, it says that through the binary number table, these two are equal. Like the 7 here, even though we have it encased inside of two quotes, which makes this 7 a string, but that 7 has a value that is the same as this number. That's how we know that that's equal. And you remember an empty string in the table over on the truthy on MDN, an empty string is false. So if 0 is false, so is this empty string. So that's what makes that equal, make that true. Now, this is where the problem comes in at. One of the things I want to tell you, in the real world of coding, you will rarely use a double equal. And we'll talk about why that in a moment, why that is in a moment. So let's get back. In order to properly make a comparison, the two operands must be the same type. If the two operands, remember what an operand is, those are two different values, to be equal or of different data types, JavaScript would implicitly convert. So you don't need to convert it. JavaScript would do it for you with the double equal sign, though. Notice it has to be the soft equal sign, so that the values are of the same data type before comparing the two. So it has to convert it. That's what it's doing. So it's already built into JavaScript to do this because of the binary numbers, because of the ASCII code. It already knows. It already knows how to convert our English language to binary code to become machine readable. And that's what it really comes down to, how the machine can see it. Before comparing the two, for this reason, the double equal operator is often said to measure loose equality. Type conversions with double equal are carried out according to a complex set of rules. Now you may want to go open up that link. It's over in MDN and it goes down here. These are the rules. You need to bookmark this and go over this. Take some time when you have some free time and read this. Put this inside of your folder on your browser that says if you don't finish reading it, read it. Now, type conversions, like we said, and while many of these conversions make some sense, others do not. For example, if we have this number function right here and we're passing the string number, it returns 7. So it makes some sense that 7 is loosely equal to the 7 string, which that's why it returns true. However, the following example leaves us scratching our heads. Okay, let's break this down. You have a string with 0 in it, and you have the 0 right there. Because of ASCII, the binary code, this is actually assigned a value of 0, so that's why that's true. 0 strictly equal to an empty string. Now remember, 0 also is set to a Boolean, which is false. That's why an empty string is false. That's why that's true. But when you put a 0 inside of a string and an empty string, it says false. Why is that? Because now it has a sequence of value, a character in there. And this is 0, but this is a different binary code here. An empty string has a different value. So that's why this is false, but this is just considered a number because it's in the string. This right here is representing 0 because of false as a Boolean, and this empty string is false. That's why we got false right there. So the double operator is non-transitive. We think of equality as being transitive. For example, if A and B are equal and B and C are equal, then A and C are also equal. However, the example above demonstrates that that is not the case for the double equal sign operator. Since double equal signs do not follow rules that are typically associated with equality, unexpected results may occur. If double equal is used in a program, thankfully JavaScript provides another operator that returns more predictable results, and that's the strictly equality sign, which is 3 equal signs. Now, you want to understand this because only in JavaScript we're doing this. In Java, we don't have a triple equal sign, but it means strict. That means not only does the binary code have to match, but the data type has to match. That's what it's telling you. It's comparing the data type with strictly equals. We always 99% of the time use strictly equals instead of double equals, because you may go through the use case. You may come up with a use case that may cause you a problem or introduce a bug down the road because you gave it a loosely equal instead of a strictly equal. So in practice, always use a strictly equal. Don't use a double equal. But we had to go over it so you can understand what it does. So here, if we go through this console.log and a strictly equal, it says the operator strictly equal compares two operands without converting. That's the key right here. It doesn't convert anything. They're data types. In other words, if A and B are different data types, says A is a string and B is a number, then A strictly equal to B will always be false. That's why this is false. That's why this is false, because the data type is a number versus a Boolean, a number versus an empty string. That's why it's false, and that's why we use strictly equal in most cases. Now, for this reason, the strictly equal operator is often said to measure strict equality. Just as equality operator double equal has the inequality operator not equal, there is also a strict inequality operator called a not strictly equal, because it has it has three spaces or three characters, but instead of having three equal signs, it has a not for one of the equal signs. The Boolean expression A not strictly equal to B returns true because it converts it. This is like a converter right here. That's what I was talking about. It can help, it would change the state of something when we put a not in front of it. So if the variable is a not, is it true, it will flip it to a false. We're going to practice that as we go forward, because sometimes it doesn't make sense and it's very confusing until you really get your head around it. Now, true when the two operands are of the different types, or if they are of the same type and have different values. So what does that mean? If A is a number and B is a string, what we're saying is A is not equal to B, so that's why it returns true, because A is not equal to B. So that's why I say you gotta play around with this, because it can confuse you. So use triple equal and not triple equal whenever possible. In this book, we will use these strict operators over the loose operators from now on. So again, check your understanding. Now, we made it to the end of this section, and I want you to go back over here and practice. Go back and understand what an expression is. Understand what a Boolean expression is. Understand what the operand is, the different, and what an operator does. Keep on testing yourself, drilling yourself on these type of things so that you can be more fluid with it. Okay? So now I'm going to say my famous saying now. I know you're probably tired of hearing it, but I'm going to keep saying it. The more you do, the more you improve. See you in the next section.